Welcome to Get Your FRQ On. In this tutorial, I'm going to show you how to use your y equals editor to graph polynomial functions and check the multiplicity of any zeros. So let's say we're working with the polynomial function and we want to know what the multiplicity of the zeros are and at least check them. Remember that the multiplicity of a zero can be determined visually from the graph, or at least most likely what that multiplicity would be. So if I go to y equals, and let's say I want to find the multiplicity of the zeros for x cubed minus 4x squared, and I also want to know what the zeros are along with those multiplicities. If it were in factored form, it would be a lot easier, but oh shucks, this one isn't. So if I click on graph, I get the graph of x cubed minus 4x squared. And recall that if the multiplicity of a zero is 1, then the polynomial will go straight through the x-axis at that 0. Notice that happens here at x equals 4. If the multiplicity is even, then we get this behavior here where the function will sort of approach the x-axis, just touch it, but then return on the same side from whence it came. And if the multiplicity is odd, greater than or equal to 3, we get that sort of cubic looking like behavior where it swoops down or up and is parallel to the x-axis and then does exactly the opposite on the way out. So with this one, I can see that it appears as if x equals 0 would have multiplicity 2. It's a cubic function, so I can't have more than 3, and I've already accounted for 1 over here. So if I want to check this, or at least verify this, give myself a much stronger reason to believe that that is in fact the case, that 0 is a multiplicity 2 root, I can just zoom in here, zoom in there, right? Still looks like it doesn't go through the x-axis. If I do it again, still looks like it doesn't go through the x-axis, and if I do it one more time, I should probably be convinced. All right, so I've now zoomed in on 0, 0 3 different times, and it still does not appear as if the graph is going through the x-axis there. So even though it's not mathematical verification that 0 is a double root of this function, I certainly have good visual evidence to suggest that it is. And so after this, I might show using synthetic division or something that 0 is in fact a double root by running through it twice and verifying it mathematically.